Welcome to Fast Math Solution on Maths with EJD. In this video, I'll be talking about the minimum spanning tree of the same problem I, you know, attempted in the previous video using Prim's algorithm. Here, we'll be focusing on the Kruskal's algorithm. So, in Prim's algorithm, we start from A and we start tracing out the all the possible places that can be reached, and then we settle for the shortest distance in each case until we connect all the cities together without forming a closed loop. Okay. And just like I said, uh, the minimum spanning tree is different from the shortest route problem. In the shortest route problem, you want to see how to go from A to I. If possible, you don't have to touch some cities, as far as you get the shortest possible distance. But in the case of minimum spanning tree, you want to touch all the cities. Imagine you want to interconnect all the 9 cities, making sure every city is connected to a telecommunications company with a mast or something like that, but then you want to see the shortest distance you need to go without having to make any extra connections. Okay. So that's a better way to look at this. Now, in the case of the Kruskal's algorithm, what you do here is you rank all the edges. The edges are the distances between the cities. So you have to rank the edges from the smallest to the biggest. And then you start adding from the smallest to the biggest, ensuring that, no city is reached more than once. I mean, or no city is reached in such a way that a cycle is formed. I think that's a better way to put it. So since we need to rank the edges, you start from the smallest, and obviously the smallest distance here is 19 kilometers, which is from H to I, that's 1. Then this next one will be 2, which is from F to G. The next one will be the third one will be 25, that's between C and F. The fourth one would be um the fourth one. What is the fourth one now? After 25, I think it's 31. Yeah. This is the fourth one. That's 31. Then the fifth one would be 40, right? There's a fifth one. 40 is the fifth one. And after 40, we have 41. That is the sixth one. After 41, we have the seventh one, which would be 42. This is this, 42. Then after 42, we have the eighth one. That's 45. So 45 are in two places. Just call them 8 and 9 respectively. Let's call them 8 and 9. So after 45, right, the next value which is the 10th one, will be 47. So you have the 10th one. Then after the 10th one now, you have the 11th one, which is 48. So 48 is the 11th one. So we are ranking the edges. So after 48, right, we have the 12th one, which would be 52. This is the 12th one. And after 52, we have the 13th, of course, another 52 from F to I. So another 52 from F to I. So we have that. That's the 13th. The 14th will be 58. 14th is 58. And the 15th is 85. 15th is 85. So we have ranked all the 15 edges in increasing order of the value of the distance. So the next thing we want to do is you start from the smallest distance and add the edges in such a way that no cycles are formed. That is no closed loop. Like say you have it is a very good example of a closed loop. Maybe something like this. Um, so you have something like this, or maybe I can even demonstrate that here. So something like this is a closed loop. Okay. Apart from that, this can also control Z or Y now. Yeah, this will also be a closed loop. Something like this is also a closed loop. Okay. Or something like this, even this would be a closed loop. So we want to avoid things like that by all means, you know. So even this, right? Even this, if you go this way and come, okay, and you have this. This is still a closed loop. So we want to avoid things like this by all means. because we just want the minimum spanning tree. Join all the cities without forming closed loops. Okay. Now, so here the algorithm is different. We start from the smallest edge. So 19 is the smallest. So with that, we add H and I to the minimum spanning tree. After 19, we have 20. So, well, with this, we are still good. F and G now have joined the minimum spanning tree. Then after that, we have 25. Okay, now C has joined. After that, we have the fourth value, which is 31. So now F and H have joined. After that, we have the fifth one, which is 40. So we can still do this joining. After that, we have the sixth one. So while you're doing this, you are making sure that no closed loop is formed. And then all the vertices or nodes are reached. So after that, we have the sixth edge in ascending order. Where's the sixth edge now? The sixth edge is this 41. Okay, we can join that. That we're still good. Then after the sixth edge now, we have the seventh edge, which is 42. We're still good. We can still do that. Then after that, we have the eighth edge, which is 45. Yeah, we can still join this eighth edge. Now, after the eighth edge, we have the ninth edge. Now, this is not necessary anymore because we have already reached. B has been reached, C has been reached. So this edge is not necessary. So we can cross that out. Okay, can just cross this out because we have B reached and C already reached. So we don't, so, there are like three rules. So you want to join all the cities in such a way that you don't need no unnecessary connection is needed. So once you reach any place once, you're good to go. And then you also don't want to form cycles. If you look around, there's no cycle at all. Imagine if I joined this, a cycle would have been formed. Thank God we don't have that. Then if I join this, a cycle would also have been formed, a closed loop. So we don't have that still. If I join this, a closed loop would have been formed, and we don't have that, so we are good. So now the ninth one, we don't need it because B and C have been joined already. Then let's see the 10th one. Do we need the 10th one? The 10th one is going to form a closed loop. You see, the ninth one is not going to form a closed loop, but it's not necessary because B and C have been reached. So the 10th one, of course, D and E have been reached, but in addition, it will also form a closed loop. Then if you look at the 11th one, uh, the 11th one, which is 48, is also not necessary because C and D have also been reached, though it won't form a closed loop, but C and D have been reached already. Then we also have the 12th one, 52. Yeah, this is not necessary also because G and H have been reached already. For the 13th one, F and I have been reached. For the 14th one, D and G have been reached already. And for the 15th one, if we do that, it will form a closed loop. And of course, B and E have been reached already. So with what we have now, we have our minimum spanning tree, because we have A reached, B, C reached, D reached, E reached, F, G, H, and I all have been reached. Okay. So in this case now, all the I can say, okay, let me go say this. Now, all the all the vertices, or what you can call nodes, all the vertices or nodes have been reached, without any cycles, without any cycles or closed loops, without any cycles or closed loops. Okay. So now the edges, the edges are, so since you are starting from the smallest to the biggest, so we have the edges as HI, which is HI. We have HI, which is 19 kilometers. We have FG, which is 20 kilometers. That's the order we went. We have CF or FC if you like. CF is 25 kilometers. We have FH. FH is 31 kilometers. Then we have BD. BD is 40 kilometers. So you can see BD 40 kilometers. Then we have EG. EG is 41 kilometers. This EG here is 41 kilometers. Then we have AE. AE is 42 kilometers. AE, this is 42 kilometers. And lastly, we have AB, which is 45 kilometers. So in total, so we have total distance. So here we have 39 kilometers. 39, right? 39 plus 25 is 64. 64 plus 31 is 95. 95 plus 40 is 135, I believe. Then 135 plus 41 is 176. Yep, 176. Okay. 176 plus 42, that's 8. That is 218. 218 plus 45 is 263. So the minimum spanning tree, the distance for the minimum spanning tree is 263 kilometers, just like what we got under the Prim's algorithm. So the two algorithms will give us the same results, and that's what we have. So it's so cool. I mean, you can apply this in case you have a telecommunications job and you want to lay cables to connect all the 9 cities without unnecessary cable laying again, right? This is one way to go. All right, so if you have not subscribed to this channel, you have so much more coming. Be sure to do that right now. Subscribe and hit the notification bell so you can always get alerted each time a new video is released. Comment. Let me know if you want me to teach a topic or solve a problem. And then like and share so that more people can have access to the great content we have here. Have a nice time. Bye.